Hello students, let us continue with the chemical thermodynamics. Next topic is internal energy U. Now every substance is associated with definite amount of energy. That amount of energy stored in substance is called as internal energy. Now this internal energy is given by capital U, and this internal energy of any substance is the sum of kinetic energy and potential energy of the particles which are present in the substance. Now in chemical thermodynamics, we don't want to know the exact value of this internal energy. We are not concerned about the exact value of internal energy. We just want to know the change in internal energy, that is delta U. We want to discuss with the change in internal energy of the substance. So delta U is given by delta U is equal to U2 minus U1, where U1 is internal energy of the system in initial state and internal energy of the substance in final state is given by U2. So we just want to know the change in internal energy of the substance or system. So it is given by delta U is equal to U2 minus U1. Now this internal energy is an extensive property. It is extensive property and a state function. It is extensive property and it is a state function. State function. Now what do you mean by extensive property? Extensive property means any property of the system that depends upon the amount of substance present in the system. Extensive property. And state function, any property of the system that depends upon the current state of the system is called as state function. That will be state function. So U is the extensive property and it is state function. Now delta U is equal to U2 minus U1. Now let us see some examples. Now if there is a system, if the amount of energy supplied to the system, the internal energy of the system will increase. Now we are supplying amount of energy in form of heat or by doing work on the system. In that case, the internal energy of the system will increase, and when the amount of energy is removed from the system, the internal energy of the system will decrease. For example, we are supplying heat to the system, and in other case we are doing work on the system by the surrounding. So the internal energy of the system will increase when the amount of energy in form of heat is removed from the system and work is done by the system on the surrounding. Work is performed by the system on the surrounding. In that case, the internal energy of the system will decrease. Anyway, you just have to remember amount of energy supplied to the system, it will be added to the internal energy of the system, and the internal energy of the system will increase. Now see some examples. First one, if 30 kilojoule of heat is supplied to the system, it will be added to the internal energy of the system, and internal energy of the system will increase. Now the change in internal energy will be given as delta U is equal to 30 kilojoule with plus sign. In second case, 20 kilojoule of work is done on the system by the surrounding. Now change in internal energy, that is delta U, will be given as delta U is equal to plus 20 kilojoule. It will be added to the internal energy of the system. The third one, if 10 kilojoule of heat is removed from the system, 10 kilojoule of heat is been removed from the system, it will be taken out from the internal energy of the system, or internal energy of the system is decreasing by 10 kilojoule, and simultaneously 15 kilojoule of work is done by the system, on the surrounding. So the internal energy of the system is again decreasing by 15 kilojoule. So overall 10 plus this minus 15. So this much amount of energy is being taken out from the system's internal energy. We can say that internal energy of the system is decreasing by 25 kilojoule. 10 plus 15, 25 kilojoule. So I will write as delta U is equal to, with minus sign, minus is equal to minus 25 kilojoule, because this much amount of energy is taken out from the internal energy of the system. Therefore, internal energy of the system will be having now minus sign, negative sign. So this was about the internal energy of the system. Every substance is associated with definite amount of energy. That amount of energy stored in substance is called as internal energy. It is given by capital U. Now, in thermodynamics, we are not concerned about the exact value of this internal energy. We just want to know the change in internal energy of the system. Now, this change in internal energy of the system is given by delta U is equal to U2 minus U1, where U1 is the internal energy of the system at final initial state, and U2 is the internal energy of the system at final state. So delta U is equal to U2 minus U1. Since this U or internal energy is an extensive property and it is a state function. Now what do you mean by extensive property and state function? Extensive property means that any property of the system that depends upon the amount of substance present in the system, that is extensive property. So internal energy is extensive property. The second is state function. Internal energy U is a state function. State function means any property of the system that depends upon the current state of the system, that is called as state function. So internal energy is a extensive property and state function. Now let us continue with the next topic. Whenever the amount of energy is supplied to the system, its internal energy will increase, and amount of energy taken out from the system, its internal energy will decrease. For example, we are supplying amount of energy by heating the system and by performing work on the system. So the internal energy of the system will increase. Now I can write it as delta U, increase in internal energy of the system, is equal to heat supplied to the system plus work done on the system by the surrounding. Delta U is equal to Q plus W. This is equation number 4.12. Equation number 4.12. Now for showing small changes or a small change in internal energy, du is equal to dq plus dw. This is equation number 4.13. This equation number 4.12 is the first law of thermodynamics. It says that delta U is equal to Q plus W. The increase in internal energy of the system is equal to heat supplied to the system plus work done on the system by the surrounding. So equation number 4.12 is the first law of thermodynamics. So this was about the formulation of first law of thermodynamics. First law of thermodynamics is the delta is equal to Q plus W. Increase in internal energy of the system is equal to heat supplied to the system plus work done on the system by the surrounding. If the amount of energy is taken out from the system, internal energy of the system will decrease, but when the amount of energy is added to the system by heating the system or by performing work on the system, the internal energy of the system will increase. So this equation number 4.12 is the first law of thermodynamics. Now formulation of first law of thermodynamics was for the formulation of first law of thermodynamics. Remaining part will continue in next lesson.